Alright, 3.6 is the last section in the chapter 3. After we finish this one, we will have the test, right? So this section, we will talk about the linear inequalities. It's not the straight line anymore. Because it's not the linear equation, it's the linear inequalities. So how can we draw a graph, the linear inequality? So basically, we need to know what is called the linear inequality in two variable. So we already know linear equation have this standard form, right? Linear equation ax plus by equals c. This is a straight line. Straight line, linear equation. Of course, the inequality should have the inequality sign. So if we have this one, or less than or equal to c, or greater than c, or greater than or equal to c. So the 4 different form for linear inequality. Of course, AB here cannot both be 0. So A and B, at least one is not 0. So first one, we want to determine the solution for the linear inequalities. If we have a paired number, right? We need to determine if that's the solution for the linear inequality. Let's check the example. For example, we have this one. And we have the linear inequality. We want to test if this ordered pair is the solution. So we only need to use the value plug into that inequality. Then we check if that inequality remains true or false, which is very similar in determining the solution for the linear equation, right? So this time we use 5 to replace the x. Then use -1 to replace the y. So on the left side, we will get 10 plus 1. And the right side, we will get 6. So that will be 11 less than 6. So let's check this inequality. Is that true or false? 11 is less than 6. Of course, it's false. 11 is greater than 6. So 11 less than 6 is false. We will get our conclusion. The point, this ordered pair is not the solution. Right? How about we have another point? We still have the same inequality. We test this point is the solution or not. We do the same thing. This time we use 2 to replace x. So we will have this, 2 to replace 6. Minus y, of course, this time we use 7 to replace y. We will get 4 minus 7 less than 6. The left side, we will get -3. And the right side, we'll get 6. So this inequality will be -3 less than 6. Is that true? Yes, it's true. So what's our conclusion? This point, this ordered pair is a solution. So that's just not hard, right? We just use the values x, y, we just use the value to replace x, y, then check if that inequality remains true or false. If it's true, then that point is the solution. If it's not, it's false, then it's not the solution. How about the second objective here is try to graphing. So we will say for this kind of problem, we have 3 steps. Step 1, we try to graph the boundary line. Graph the boundary line. So that is try to graph the straight line first. We treated the inequality as the equation. Then we can find the boundary line. So graph the linear equation. Actually, the first step is try to graph the linear equation. Step 2. Step 2, we should pick a point. Pick a point, but this point should not on the boundary line. On the boundary line. This point, we want to pick a point. Then we test this point. Test this point if it is the solution. We just tested this point called. And this point can be any point not on the boundary line. Step 3, we should get a conclusion from part B. If the point is the solution, if yes, it's the solution, then we should shade it. Shaded the half plane contain this point. But if the point is not the solution, then we shaded the half plane without the point. So that's the 3 steps rule for graphing a linear inequality. Again, first step, we treat the inequality to be the equation. So that is try to graph the straight line. Try to graph a straight line. Then second step, we need to set a point. This point can be any point, but not on the boundary line. Then we test this point if it's the solution for the inequality. For the inequality, this time we should use inequality. Then step 3, we get to the conclusion based on the point. If the point is the solution of the inequality, then we should shade the half plane contain this point. If it's not the solution, then we should shade the half plane without that point. Let's check the example. So we should graph this inequality. So step 1, remember, we should treat this one as the linear equation. we should treat it as the straight line. So it's the equation, not inequality. We should change the less than sign to the equal sign to make sure we can draw the boundary line, right? So this time, we only need to draw the straight line here. How can we draw the straight line? We need to set several points, right? We should set a point. So if we set x equal to 0, then y will be equal to 7. So we have the first point, 0, 7. This is also our y-intercept. So next time we set y to be 0, then x equal to 7. So this one is also our x-intercept, y equal to 0. So we could just help us to draw the line, draw the boundary line. So for the first y-intercept, x equal to 0. So we have 0, 7 right here. And the second will be x-intercept, y equal to 0. So it's right here, 7, 0. Of course, we could draw the line. But here comes the problem. Should we draw a straight line, a solid straight line, or dash straight line? We have the question. Then we go back to check the original inequality. We realize it's the negative, it's the less than sign without equal sign. So, which means any point in this straight line is not the solution. Any point in this straight line, in this boundary line, is not included, is not the solution. So which means we should have this as our boundary line, but all the points on this boundary line is not our solution. That's why we should put a dash line. We do not contain the equal sign for our original inequality. But if sometimes we have like this one, we also have the equal sign, less than equal to 7, which means it's possible to get this one. So all the points on this boundary are also our solution. So we should include all the points on this line. Then we should draw a solid line. But in this case, all the points on this boundary line are not the solution. That's why we put a dash line here. So first step, we already draw our boundary line. This time the boundary line is a dash line, because we do not have the equal sign in our original inequality. Then we move to the second step. We set a point. We choose a point not on the boundary line, not the boundary line. Not the boundary line, so we can randomly pick one. Let's say, I prefer to pick 2, 2, let's say. Pick this one. It's not on the boundary line, obviously, right? 2, 2. Let's set this one, 2, 2. Then we go back to the original one to test if it's the solution. So we have this one. We use 2 to replace x and also 2 to replace y. Then we check the left side, we'll get 4, and the inequality to be 4 is less than 7. Then we will say it's true. The inequality remains true. 4 is less than 7. So if it's true, then we know this 2.2 is a solution, right? If it is a solution, then we can move to step 3. If it is the solution, so we should shade the half plane with that one. Include this point because we know this one is the solution. Then we know the whole half, the half plane include this point will be our solution set. Okay? So we just shade the half plane include 2.2. So we finish our graph. But sometimes, of course, sometimes we can pick, let's see, the 6, 8, this point. We can pick this point. If we, step 2, we pick 6, 8 as our solution. We still go back to the original inequality. This time we use 6 to replace x and 8 to replace y. Then we check the left side, we'll get 14, and right side it's 7. Let's check the inequality. 14 is less than 7, which means it's fourth, right? It's fourth. Then we go back to step 3. So the boundary sets the whole plane into 2 halves. And if this one is the fourth one, we should shade it the part without this one. So it's remain the same part. We will get the same graph. So 2 things are important. The first one, we should determine if the boundary line is dashed line or a solid line. Depends on the original inequality sign. If it has less than or equal to, has the equal sign in it, it should be a solid line. If it's just less than, greater than, without the equal sign, so that will be a dashed line. Okay? Another important thing is we need to pick a point not just on the boundary line. If that point is the solution, then we should shade it the part with that point. If it's not, then we should shade it the part without that one. Okay, so that's for the graphing. And that's all for the chapter 3.